So this session is just an open kind of session for you guys to ask questions and for us to work on stuff together. So I don't really have a hello, hi, all three of you. I don't really have a plan other than to answer. So if you want to grab your textbooks, or if you want to ask questions of something else, I mean, I guess the textbook would be the best. And let's kind of just make sure we focus on Module 7. So your session, guys. So you get to pick, this is you, okay? And you are going to talk to me through your chat, right? And you're going to tell me, Mr. Weicker, I have questions about this. And then I'm going to be over here, you know, with my smiles right there. This is my beard, okay? And I'm going to be saying, oh, you didn't, okay, let's talk about your questions, okay? Lovely drawing, right? Okay, so yeah, kind of just gonna wait on you guys. I know it's kind of new and on the spot, but yeah, I know. My drawing's not that great. But yeah, go ahead and go grab your textbooks, your workbooks. If you have any questions, maybe you don't, and so you just wanna just watch and as questions arise, but kind of going to wait on you guys. I suppose I could have had some questions picked out. Maybe I will do that next time. I am glad, Mega HBot, that you like doing this. I do too. I think it's a pretty technology to do something like this. So I did hear that some of you were having questions about the converting between measurement systems, like lesson 7.4. I did have a live session last week, and I went through and taught this to 2 students, and it was an experiment, and it didn't go super fantastic on my part. We had a lot of technical issues, but I think that I've been able to solve most of those. So we can talk about that too. Okay, well, okay, good question. How do you convert inches to centimeters? Okay, now if you have your workbook and you turn to page 194, is the key. In fact, let me do this. Page 194 has the key that you will need, because it's going to have this kind of these two tables like this, and one says customary metric conversion and the other is metric to customary. And basically you see that they're broken into 3 things. You'll have length and weight and mass and capacity. Okay, this is terrible. I should have just copied and pasted this in somehow, but I don't want to waste our time doing that real quick. Is going to tell you how much, for instance, 1 inch, how many, centimeters are in 1 inch. So the very first thing we see in the length of customary to metric is that 1 inch is equal to 2/54 centimeters. So if your question is how do you convert inches to centimeters, and let's say you have a 3-inch long, like a worm, okay? It's fine, you found a worm that's 3 inches, and you're like, I wonder how many centimeters that is. Okay, that's exactly what we're talking about right now. And what you would do then is you would recognize that you have a ratio, that we basically have 2 ratios and proportions that we can use to solve this. And so that would look something like this. if I take the inches, so I would say that is for every 1 inch, there are 2 5/4 centimeters. I need to put my units. There's one ratio that we have. 1 inch is to every 2.54. You could flip it around. You could say 2.54 centimeters to every 1 inch. Doesn't matter, right, in the ratio. But this will help us down here because we can recognize that we have another ratio, like 3 inches, because right, we have inches on top, so we're going to put inches on the top. What do you think we're going to put on the bottom then? I mean, at this point, it's a big we don't know, right? But I hope that what you're seeing is something familiar. We can take this guy. I wish I could just grab it, but I can't. And we can write him over here. And maybe this will help you like this before. Oops. No. Sorry. I'm just going to leave it like this because we don't know it yet. And if I put an equal sign here, now this should look very familiar because this is a proportion, right? We are saying that these two ratios are equivalent. It's just that we have to find out what would go here that would make this equivalent. And what do you know? How do we go from 1 something to 3 somethings? Well, if we want 3 of these ones, then we need to what? Multiply by 3, right? And you have the answer. Good. You guys are probably going to work a lot quicker than me here, but I just want to make sure I'm spelling this stuff out for you. Case though for the numerator, then you guys already know that that's also the case for the denominator. No, since we're asking the question, hey, this worm is 3 inches. I wonder how many centimeters that is. Well, we know that 1 inch is equivalent to 3 inches only if we have the same equivalent, not 1 inch is equivalent to 3 inches, but 1 inch to 2.54 centimeters to every 2.54 centimeters is 1 inch. Then we can multiply this by 3 and we'll find out. So let's do that. Let me just, sorry, I can stop talking and actually do the math. 2.54 and we want 3 of them. We're going to do 3 times 4. 3 times 4 is 12, and then 3 times 5 is 15 plus 1, so that's 16. And then 3 times 2 is 6 plus 1 is 7. Did I do that right? Remember, and when we're dealing with decimals, we're going to count the spaces that the digits are, 1, 2, like that. And that means that we're going to go 1, 2, like that. And so we have, so if we want to know, hey, this 3 inch long worm, how many centimeters is it? We just found that it is 7 62/100 centimeters. And we have this proportion, 1 inch. So every 2.54 centimeters, for every 3 inches, there are going to be 7.62. Oh, and I was running off the screen, you guys. I'm sorry about that. Let me see if I can better. There we go. Hopefully that'll everything. See it now? Let me check what you guys can see. Okay. Better. All right. Yay, good. Okay, so that's how you would convert inches to centimeters. You got it. So I'm going to clear this. Well, actually, before I do that, don't forget to go to page 194 because that's where I'm getting all this information. Like, I don't have this stuff memorized. I couldn't tell you off the top of my head 1 gram equals how many ounces. I need to look at some kind of table, and what do you know? 1 gram equals or is equivalent to 0.035 ounces. If I look, I think it's like right here on the table. So that table is going to be your best friend for answering a lot of these conversion questions. All right, I'm going to erase this now. Page 194. Don't forget it. I'll just write it back over here. Page 194. What other questions, guys? What else? Do you see any other problems that I could do for you or we could work out together? Is there any in the independent practice or guided practice or any of those other concepts Or we can do another problem like this one. Conversion tables. Oh, I just told you, don't memorize them. I mean, if you want to, go for it, but don't memorize these. That's not necessary. Job and out, later on in life, you're a construction worker or something, then maybe it will be someone who, or even a baker, someone who's working with measurements a lot, then you be worth it to do that, maybe. But I don't want you guys to memorize them right now. Okay, it's not necessary because we can always search for it on page 194. We can Google it, things like that. So, what do you guys want to do? Yeah. Mr. Dolphin, could you like what you're talking about with division? Are you thinking 7.4? I'm trying to figure out if there are ones with division in 7.4. Let me here for myself. Do you guys want to go over the any of the ready to go on stuff or independent practice? I'm getting one request to do one with division. I'm just trying to find one that would do that. Okay, you might have done this one, but I'm gonna do number 7 on page 196. It says a flower bed is 2 meters wide. So I'm just gonna stop there and I'm gonna draw myself a rectangle because I heard the word wide, and I'm gonna say 2 meters. Okay, so this is the flower bed. It's 2 meters wide, 3 meters long. Oh, okay. Well, I'm gonna change my. I should have read a little more. There we go. 3 meters long, 2 meters wide. So, however we turn that, it's something like this. Okay. What is the area of the flower bed in square feet? Round your answer to the nearest hundredth. All right. So the question here is, what is the area of this in square feet? Do we? Well, first of all, are we dealing with feet? What do you guys think? By the way, are you guys' comments still working? Are you still there? Is it still? Am I still? Everything's still working? Yeah. Hopefully. Okay. All right. Good. Okay. So again, we're doing number 7 on page 196. So we're asking ourselves, what is the area of this in square feet? But I want you to notice that we aren't dealing with feet right now. We're dealing with meters. So if we found the area with using just these numbers, we would have the area in square meters, not feet. Okay. And the question is asking, what is this in square feet? In fact, we want to know, what is it in square? Okay, so we need to change this, and we need to change this to feet. So before we do any figuring out of area, we need to do conversion. And so we're going to change this to feet and this to feet. We're going to go to our table, our handy dandy table on page 194, and I'm going to look. I'm going to see what is meters to feet. Meters to feet. Do you guys see it? You find it before me? Meters to feet. Okay, it is telling us that 1 meter, so we're going to write this somewhere else. I'm going to get a different color. 1 meter, which means it's not exactly this amount, but it's we round it to this, and so we're going to just use it instead of using a bunch of decimals. So sorry, 1 meter is equal to 3.28 feet. Okay, so we can write it like that. We can also write it like a ratio, which is actually going to be more helpful to us, right? For every 1 meter, there are 8 feet, and that's helpful because now we can make a proportion using the information here. So which one do we want to convert first? Because we all do one at a time. Might as well do this one. Okay. So I'm going to put up here, right? I'm just taking this and I'm putting it here because we're converting. Just using 1 meter, we're going to 3 meters, and so if we're going to have 3 times this much. That means we need 3 times this much, right? So times 3 times 3. So that means we're going to need to do a little math right here. Have pencil and paper with you. I forget thing out a lot. Let me know. Yeah, let me know if I cut out completely or something like that, okay? Because I don't want that to happen. But hopefully, again, you guys, I want you to bring paper and pencil when you come to these because I don't want to be doing all the work, and it's good practice for you as well. And there might be times where I ask you to complete something on your own. So here we go. 3 times 8. I'm just going to do it partial method. So 3 times 20 is 60. You might do this a little differently. That's okay. 3 times 300 is 900. So I have all this. Oh, that's actually not 300, is it? It's 3 ones. I forgot about the decimal. That's okay. So I'm going to add these up. I've got 4 ones and 4 hundredths, 8 tenths, and 9 1. And again, there's 2 spaces, so that's 2 spaces there. So here we know that 9.84 feet is to every 3 meters. So we now know this side. So I can write right there. That's 9.84, okay? Feet. We need to figure out our 2 meters. So I'm going to do the same thing. I'm going to do the 1 meter, 8.28 feet, and we're going to convert it to this time to 2, right? 2 meters. And so how do we go from 1 to 2? By 2. That means we're going to do here multiply by 2. So we need to do 3 multiplied by 2, 16. That'll give me 4 plus 1 is 5, and that'll be 6. And the decimal goes there because I got two spaces. So we now know that this is equal to 6.56. You know, I'm going to try and rearrange myself here for a second. Someone already has the answer. Good, good, good. You got the answer for the 3 meters. Good, excellent. So now we have the feet wide and the feet long. And now, confuse ourselves, let's get rid of the meters. We don't need them anymore. We're now going to use this data and this data. And because we know the length and the width, or length and width, whichever way you want to say it, we know that area, to find it, you multiply the length times the width, or the side times side, okay? So we're going to do that. So the area for this figure is going to be this guy, right? 9.84 feet multiplied by this guy, 6.56 feet, and that'll give us our area in feet, right? So we need to do the math. And division, I hope that's okay, but you would then set it up, you know, something like this. and you do all that fun math, okay? You'd multiply it all out, you'd come up with 4 and 55 hundredths square feet, and that would be, yeah, which is right, the inside of this shape, the amount of square feet that are covered in this inside, in the interior of this flower bed. Well, we got to remember we're talking about flower bed, huh? Was that helpful? Oh, is it not 6.56? Maybe did I do my math wrong? Someone's saying possibly. Let's see. So we got 16, carry the 1, then 2 times 2 plus 1 is 5. And yeah, that should be right. 6.56. Yeah, because Mr. Dolphin, if you look right here, 2 times 5, I'm sorry, 2 times 3, excuse me, is 6, not 5. 2 times 3 is 6. Is that good, guys? So again, we were given data in meters, but we wanted an answer in feet squared or square feet. So we had to change our meters to feet. Looking at our table, right, making the ratio, converting. Then we had our data that we needed. We had the width and the length in feet, and so we can multiply them and get the area. Is my math cut off again on the bottom? It is. Sorry. Let's see. How does that look? That looks better. Yeah, I think so. Okay. Oh, you guys are seeing all this business up here too, huh? It's okay. I wonder if I can hide it. Space. What else can I help you with here? What's another thing we could do? Thought maybe it was that you added 2 plus 3 is 5, but remember this is multiplying. 2 times 3, or 2 threes is 6. Another problem? I'm going to go to the independent practice, okay? Tough one. Okay, I'm going to look at, you know what? I'm going to do something that might help us. Where's my, can I get my bookmark back? We want the Monday class, Monday math, there we go. Student book. Nope, not what I wanted. There we go. Guys, sorry, this is something I'm learning. I should have something like this pulled up already. What I'm going to do is I'm trying to get your textbook here on screen. Interactive student online edition. I think this is what we want. Yeah, we're gonna do more problems. Let me just let me pull up your math book so that we can look at it together. Can you see that? Yeah, oh good, you can see it, okay. We're zoomed in way too much though, right? Let's see, how do I do that? Page view, come on here. Okay. That's too small. Too small. Sorry. And that's too big. Okay, well, it's okay. Yes, awkward silence. There are going to be a lot of awkward silences in this this venture of live online classes sessions. I was just saying, I was thinking to go to independent practice if you guys are all right with that. And I want to do kind of a difficult one just so we can do that together. So I believe I'm on page, what is this, 198? Page 198. Let's try 33, okay? You weigh a gallon of 2% milk in class, in science class, and you learn that it is approximately 8.4 pounds. Okay, so just so I remember, and I know this is kind of silly, but it just helps me remember, okay? It just helps me remember. So I'm going to put an M for milk. You take your milk to class. I was saying something. You weighed it, so it's 2% milk. I don't know if that's important, but 2% milk. And approximately 8.4 pounds, okay? Put it on a scale. Scale says 8.4 pounds. By the way, pounds is LBS, okay? I know it looks like 16 or something, but it's LBS. So that's 8.4 pounds. Pass the milk to the next group, and you realize that your teacher wanted an answer in kilograms. Oh! So explain how you could adjust your answer without making another measurement. So you don't get the scale back, and you want to know how much it weighs in kilograms. Explain how you would adjust it, then give the mass, okay? So they first want us to explain. How would we figure out how much this milk weighs in pounds if we don't have a scale anymore? We have data, right? Oops, we have data. And we also have a conversion table on page 194. We also have Google, right? Where we could look up, hey, how many pounds are there in a kilogram? And that's actually our question, right? Pounds. Pound is how many kilograms? That's what we need to know, because then we can just convert 1 pound to 8.4 pounds and do the same over here. Whatever we do to convert 1 to 8.4, we're going to do the same thing to this to get how many kilograms. So, well, do you guys look on your table? What conversion? What's pounds to kilograms? Or is that on the table? Maybe that's a question we needed to think about too. Oh, and I have it. We can look at it right here. Somewhere. Sorry, what page 194? Ah, here it is. Here it is. Here we go. Okay. Pounds to kilograms. Hey, there it is, right there. Okay. So 0.454. Oh, I'm going to need more space. Okay. 0.454 kilograms. All right. So this is true. 1 pound is approximately 0.454 kilograms. Let's double check. 1 pound. Yep. Okay, good. Well, this is totally helpful because, again, we just need to know how to go from 1 to 8.4, and then we'll do the same thing over here. Well, how do we go from 1 to 8.4? You guys tell me. 0.4. How did we go from 1, or how do we go from 1 pound to 8.4 pounds? I'll wait for you guys. Question is, how do we go from 1? Ah, thank you, Mega HBot. Am I pronouncing that right? Mega HBot. We're going to multiply it by 8.4. To go from here to here, we multiply. So you guys, we don't need to even say this. To go from here to here is going to be the same thing. Multiply by 1, and that would be 8.4 over 8.4. All right. So we're going to do that. We're going to do the math. Would you do that, please? Would you find out what this would be? Because if we have 8.4 of these, then that'll tell us how many kilograms. Actually, let's race, all right? Let's see who gets this done first. I'll go to. Remember, when you multiply, you don't need to line up the decimals. So 4 times 4 is 16. How am I going to do this? 5 times 4 is 20, plus 1 is 21. 4 times 4 is 16, plus 2 is 18. Plus 1 is 1. Now we're in the 10, the next place over. So 8 times 4 is 32. 40 plus 3 is 43. 8 times 4 is 32, plus 4 is 36. Plus 3 is 3. Ooh, I'm running out of space. I'm going to put my answer over here. It's going to be something like 6, 3, 11, 3. Now I just need to figure out where to put the decimal, and 1, 2, 3, 4. So you notice that 1, 2, 3, 4, right? Just count all of those. So that's what I'm going to do over here. I'm going to go 1, 2, 3, 4. So it's going to go right there. Well, unless there's lag, I'm not sure if there's lag or not, but looks like I beat you guys. I'm just saying. I mean, I don't mean to say who did better, who's quicker, but oh, you can't see me smiling right now. Sorry. So the point though is the number. What is it telling us though, right? What is this? 3.8136 cows. And do we really want this much? I mean, depends what units we're looking for. Oh no, someone got a different answer than I did. Did I do my math wrong? 4 times 4, 16. 16, 18. 1. Okay, that's right. 8 times 4, 32. 43. 32. This is right. This is right. Did I add it right? 6, 3, 8, 3. No, this is correct. This is correct. All right. Oh, good, good, good. You guys got some too. Okay. Nice. All right. So what is this, guys? Is it ice cream, cows, dump trucks? What are we looking at right there? Yes, I am a math teacher. I am a math teacher. I'm a teacher, yes. But you know what? You guys know how to do this as well as I do. All right. Seriously, we just talked about it. You guys could be math teachers on this as well. But I want to know, what is the units here? What is this? Nobody's telling me. Am I gonna have to spell this out for you guys? What did we just convert? What did we just figure? Yeah, it's kilograms. It's kilograms, right? If we look back to our problem, we just wanted to go from pounds. We had this milk that weighs 8.4 pounds, but we want to know what it is in kilograms. So we needed to go to our conversion table and figure out, okay, how many pounds are equivalent, pound is equivalent to how many kilograms. So we found that. We converted 1 pound to 8.4 pounds, not convert, but we multiplied. We changed this to 8.4. So we needed 8.4 of these, did that, found this. So our 2% milk in kilograms weighs exactly 3 and tenths, hundredths, thousandths, 10,000, 136 10,000ths. I don't know, 3.8136 kilograms. Milk, yeah, milk, kilograms of milk. Good. Another problem? What do you guys think? How about we go for 10 more minutes and we'll be done, okay? Anything that stuck out to you? Any questions? Anything from like 7.1? So ratios, rates, tables, graphs, applying ratios and rates, converting within measurement systems, converting between measurement systems. What do you think? So any of module 7, remember, today I pushed out that module 7 assessment, so it's that final test. You're free to take it today, tomorrow, Friday, or even next week. I can help right now review anything that if you'd like. I'm looking down here at are ready to go on. Laps around a track. The table shows how long it will take him to run different numbers of laps. How long would it take Charlie to run 5 laps? Okay, so here's the number of laps, like how many he runs, and here's the amount of time it takes him. So how long would it take Charlie to run 5 laps? Well, we don't have on here, right? 2, 4, 6, 5 would be somewhere right here. Actually, this is an easy one we can just think about, because look, 2 to 10. Well, look at the pattern, right? 10 to 20 to 30 to 40 to 50. So halfway between here and here. We want halfway between 4 and 6. So that means we also want halfway between 20 and 30, right? Halfway between 4 and 6 is 5, and 30 is 25. So how long would it take Charlie to run 5 laps? 25, because it'd be 5 to 25. Figure this out another way, because if we figured out the unit rate here, if we made this 1, go back to where it would be 1, what would this be? Like, what is this? Well, if we take out a 2 from both, it would be 1 to 5, and that's what we'd start with, 1 to 5. And if we wanted to know how much, 1 to 5 is, if he ran 5 laps instead of 1, just like what we've been doing. How do we go from there to there? Multiply by 5. So how do we go from here to here? Multiply by 5. 5 times 5, 25. So how long would it take Charlie to run 5 laps? 25 minutes. Make sure we get those units. Graphs. Somebody's saying graphs. All right. Let's do that. Let's look at graphs. I think that was in 7.1. Am I correct? Go this way. 7.1. Oh, and just lost part of my page. If you guys want to turn to 7.1, I think that's where I'm going to head right now. If these pages show up. Module 6. Okay. Here we go. All right. Ratios from tables, we want graphs. All right, let's take a look at this one right here. A shower uses 12 gallons of water in 3 minutes. See, that's a ratio. 12 gallons of water in 3 minutes. 12 gallons of water, 3 minutes. Okay, I don't even know if this is going to be helpful, but I'm going to write it down because it's data from the question, and it's ratio. Shower uses 12 gallons of water in 3 minutes. Complete the table and the graph. Suppose the shower used 32 gallons of water. How long did it take? Oh, so given this table, so if we were to make this table, let me try to do that real quick, guys. How many? 3, 4, 5. 2, 3, 5. Okay. And time and water. And we're given 2, 3, 20, and 6. All right, just so you guys can see what I'm doing, I'm just trying to recreate that table right here. Oh, sorry. Thank you. I should be telling the page number, shouldn't I? Oh yeah, you want to do page 177. Okay. Would you guys rather work on that? Or not? I'm currently at the bottom of page 175. Just a second. Okay, sorry. Let's just stick with this problem. Just because it seems like it'd be short enough for us to work on. I'm sorry if I'm keep cutting out. Let's just try this, okay? So the shower uses 12 gallons of water in 3 minutes. Oh, here's 3 minutes, and we were just told that it uses 12 gallons, so we can fill in part of our table every 3 minutes, okay? Complete the table and graph. Okay, so let's complete the table first. I'm gonna look for patterns first of all. 2, 3, 4, blank, 6. I wonder what this could be. Blank, 12, blank, 20. Okay, so this might be a little trickier, but another pattern that we can look at is the ratios here. These are ratios, 2 to something, which is equivalent to 3 to 12, which is equivalent to 4 to something, which is equivalent to 5 to 20. So we know 2 of the ratios, and actually 2 of them, but let's just stick with 3 to 12. And can we simplify this? Can we find out what the unit rate would be? Unit rate would be taking one of these, either one, and making them 1. Well, it's easier for us to take 3, and it would be 12. Just trust me on this point. So I'm going to take 3 and I'm going to make it be 1. Now I'm going to ask myself, how did I go from 3 to 1? Well, I divided this by 3, right? Here, I divided by 3. And you guys know, then to not break math, we need to do that also to the bottom. Divide this by 3, and that's going to be 4. So we now know something very important. For every 1 time, what's this, minutes? So for every 1 minute, we use up 4 gallons. That's super helpful because that means for 2 minutes, that's double this, which would be double this, right? We're not doing 1 minute, we're doing 2 minutes. So we're going to do 2 minutes, which means we'll do double this to get the water. So doubling this will give us 8. Same thing, let's look at this one. So how did we go from 1 minute to 4 minute? Well, we have 4 of these, right? We did this 4 times to get this. So that means we need to do this 4 times to get 4 times 4, 16. And lastly, from 1 to 6, we're going to multiply by 6. That means we're going to multiply this by 6, and we're going to get 24. Okay, so that's how we fill in the table. So now we're going to take a look at the graph. I wish I could draw right on here. Oh, can I? I don't think so. Darn. Okay, so let's fill in this graph. So we have water used in gallons and time. Water used in gallons and time. Let me see. All right, just so you guys can see what I'm doing water in gallons, time in minutes, and then what was it giving us? It looks like each of these steps 0. These are 4 jumps of 4, right? Okay. So we know 0's here, and 4, 8. Whoops, wait. I got a better tool. 4, 8, 12, 16, 20. Whoa, whoa. 20, 24, 28, 32, 40. I think it went to 40. 40. This is 4. We can figure out the rest in between. And then we have 0, 1, 2, 3, 4. Okay, all the way to 10. It's good. It's easy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now we're going to fill in this according to our table information. So let's start here. For every 2 minutes, we use 8 gallons of water. So every 2 minutes, so here's minutes, we need 2 minutes, we use 8 gallons of water. So we need to go 2 minutes and we need to go 8 gallons of water. So wherever 2 minutes and 8 gallons of water meet, which would be right there, our first dot. That was pretty pathetic. Something like that, right? That's where 2 minutes meets 8 gallons, right there. So let's do 3 gallons, I'm sorry, 3 minutes and 12 gallons. 3 minutes, so 3 minutes is here. 12 gallons is 4, 8, 12. Right there. If I had grid paper, this would be much better, right? How about these coordinates? We have 4 minutes, so we need to look at our minutes. 1, 2, 3, 4. So I'm going to put a dot right there. And 16 gallons. 4, 8, 12, 16. So it looks like if I follow this line down and I find out where it intersects the other line, it would be somewhere right there. So I'm going to draw my line 4, 8, 12, 16, right? I should do all these the same color, but sorry. 5 and 20. 5 minutes. 5 minutes. 1, 2, 3, 4, 5 minutes. Right there. And 20 gallons. 4, 8, 12, 16, 20. There. And last, we're going to have 6 minutes and 24. And what do you know? It's going to be right. Look at these plotted oh, goodbye, Miss A. I'm not going to say your name. I don't want to say your name on here, but at your yoga class. If you have any questions, contact me through Google Classroom. So I plotted all those points. Any questions about how I did this? How I took this data and I put it onto this graph? Any questions? It's corresponding to the gallons, and I made sure I found a spot where they intersected. So 2 minutes to 8 gallons. 2 minutes to 8 gallons right there. That was a pretty bad dot. It should have been more like right there, but that's our 2 to 8. We write this small enough. It would be x would be 2, 8. That's the coordinate point for that. 2, 8, right? Because we have 2 right here and 8 right here, and they intersect right there. Then we had one right here. This is 3, and this must be 12. And what do you know? We follow out where they intersect. We have 3, 12. Whoops. Okay, we plotted that point. Now we've okay. What question might you have here? I'm seeing someone's not understanding. What if I this okay, time? So this is minutes. This is all minutes, and this is gallons. So I took where the 2 is, right there, and the 8, because this is our ratio. This is data for one spot, right? For every 2 minutes, there's going to be 8 gallons of water used. So for every 2 minutes, I'm going to plot where 2 minutes and 8 gallons of water being used are, and that would be right there. See how 8 gallons comes here and 2 gallons goes there? 2 minutes, 8 gallons, they intersect right here. That point is plotted. And then if we move to the next one, or if we even move, let's just move down here to this guy. It's 24 gallons. So we're going to go to 6 minutes. 4, 5, 6 minutes. If I were to, 6 minutes is right there. And why did I put it so high up there? Because remember from our table, 24 minutes. 24 minutes. And 24 happens to be right there. If I can follow 24 over, boom. So there's our 6 minutes using 24 gallons of water. That's fine. You know what? We need to wrap it up. Oh, I'm glad you understand. I know we only got to a couple questions. I hope this was helpful for the couple of you that joined me. I'll probably try to save this recording and post it on the classroom just in case anybody else had the same questions that you did. Thanks for participating. Again, if you have any further questions, you can comment to me through Google Classroom. But thank you guys for your time, and I will talk to you guys later.